This is the display of an oscilloscope. It's configured to show voltage on the left-hand vertical scale and time on the right-hand bottom scale. Voltage is measured from 0 to 10 at maximum, both positive and negative. And the bottom scale here, each division is 1 millisecond. So what we're seeing is the output signal of a Caterpillar 2661466 pulse width modulated, or PWM, position sensor. So this sensor is outputting a pulse 492 times per second, or a signal of 492 hertz. The hertz, or the frequency of these signal pulses, stays the same. So as I vary the position, you can see that the frequency does not change. The duration of the signal pulse can be anywhere from a very short period of time all the way up to a very long period of time. So it can be from less than a millisecond all the way up to almost 2 milliseconds. What we are actually measuring is the percentage of on-time voltage present to the off-time or no voltage present. And that is displayed in positive duty cycle. So as I change the position of the sensor, you can see that the duty cycle changes quite a bit. Our absolute minimum in this case is 3.4% on versus off time, all the way up to 93.8% on versus off time. Also notice the maximum and minimum voltage of the signal. At maximum, the signal is approximately 8.2 volts, and at minimum, it is hovering right around 0 volts. Notice that as the position changes, the voltage does not change. The frequency and voltage of a PWM signal do not change. Only the relative on versus off time as a percentage changes. It never goes to 0, and it never goes all the way to 100%. These signals are very resistant to interference. In particular, they are not affected by high resistance in wires or connections, because the ECM can recognize an on time anywhere between 8 and approximately 5 volts. And the voltage for the off can be anywhere from 1 to 0 volts, and the ECM will still recognize the signal as valid and can measure the on versus the off time.